for the remainder of this lesson, we're going to look at a couple of other applications. And you guys, there are tons of applications of right triangles, so I just picked a couple. This first one is called the subtense bar method. And this is a method that surveyors use to determine a very small distance d between 2 points P and Q. And what we like about it is that you can use it to measure more precisely and to more significant digits than a tape measure can do. So that's why they do it. When you're looking at a small distance where you want to go to a lot of decimal places, this is what they use. So here's what they do. They take a subtense bar that is measured very, very precisely, and it has a length, in this case, of what we call B. Okay? And it is centered at a point Q. And the angle theta is measured, all right, from the point in question to the ends of the subtense bar. And that will allow us to use right triangles to figure out the distance between P and Q, which they have labeled D. Okay? So here's what they do. They stand at one point, okay, and then they come over here and they lay their subtense bar down, all right? And then they measure, and they lay it perpendicularly to this distance. And then they measure the angle, and that will allow them to cut that subtense bar in half, which comes from the factory, very, very precisely, made to be a certain length, and make two right triangles out of it. It's very, very basic concept. Now you only have to worry about one of those right triangles, and they give you some information. They said in this triangle, theta is 1 degree, 23 minutes, and 12 seconds. Now that's the whole angle, so we have to be really careful with that. That's the whole angle. Y'all understand that? Okay. And then the whole subtense bar is 2.0000 centimeters. We want to use some trig to figure out how far it is from P to Q. So basically, I'm just going to take one of those triangles and I'm going to redraw it down here. So this is P. This is still Q. And I'm only going to look at the upper triangle. I'm going to relabel it. Okay? If B is 2.0000, what is half of it? Just this upper half here. 1.0000 centimeters, right? Okay. If theta is 1 degree, 23 minutes and 12 seconds, we have to figure out a way to take half of that. Now the easiest thing to me is to convert that to a decimal and then take half. You guys okay with that? Okay, so we're going to type this in our calculator. 1 plus 23 over 60 plus 12 over what? 3,600. And you're going to give that to me with as many decimal places as you can, and that's going to be my angle. So what is half of theta?
1.386.
Hold on, let's pause. That's theta. Theta is
1.38666666.
it's 1.3866. A bunch of sixes? Okay. But y'all, that's all of theta. In this thing, I just want half. So now I have to divide it by 2. Okay. And that's half of theta. Theta over 2 is?
0.69333333.
Okay, a bunch of 3's. That's going to be theta. 0.693333 degrees. And I would like to find this distance right here. Is that a tangent equation, a cosine equation, or a sine equation?
Tangent.
See, that is opposite over adjacent. So you are right, that is a tangent equation. So we know that tangent of half of theta, 0.693333, and carry as many decimal places as your calculator will tell you, degrees, has to equal 1 over d. So 1 over d. Then you just cross multiply and solve it for d. So it looks like d times tangent of 0.693 with a bunch of 3's has to equal 1. So it looks like D is 1 divided by the tangent of that angle you just found. So let's pause and let you calculate that. All right, when you said 1 divided by tangent of 0.693333333, did you get 82.634,109 blah, blah, blah?
Yeah.
Okay. How many significant digits do I go to from the given problem? Let's count.
5.
This is 1, 2, 3, 4, 5, and this one is 1, 2, 3, 4, 5, and you use the smallest, but they're the same, so we're going to go to 5. So that's going to give me 82.634 centimeters, okay, which is much more exact than any tape measure could ever hope to do. And so that's a lot more precise, not exact, but a lot more, accurate, and to the smallest unit.
Well, even though we use calculator, isn't there really because that precise more digits than what it gives us?
There are more digits than what it gives you. However, realistically you can't measure better than what your originals were measured in, and so that's why those don't matter. Okay? All right, is that good?